In this video, we're going to be taking a look at how you can compare volumes. Now, the essential question we're going to take a look at is how can you use the strategy make a table to compare different rectangular prisms with the same volume. Now, we are going to unlock the problem, and just like with any type of problem-solving type problem, there are certain steps that we're going to follow. Okay, and we're going to do that. First of all, obviously, you need to read the problem. Okay, so the problem reads, Adam has 51-inch cubes. The cubes measure 1 inch on each edge. Adam wonders how many rectangular prisms, each with a different size base, that he could make with all of the 1-inch cubes. Now, some things that you need to follow along with me as I go through this. 3 questions we always ask ourselves right from the very beginning. What do I need to find? What information do I need to use? And also, how will I use the information in order to solve the problem? Okay, so first of all, what do I need to find? So I need to find the number of, okay, we can see rectangular prisms, each with a different size base that have the volume of 50 cubic inches. Okay, so basically what we're doing is just trying to rethink the question that is asked us and really focus in on that and not get distracted with any extra information that the problem may be giving us. Okay, now what information do I need to use? Okay, we can use the formula volume equals length times width times height, or volume equals base area times height. Okay, either of those two will do. Okay, and also the factors of 50. Okay, so those are important to think about as well. All right, now how will I use the information? Some things that we need to think about. We're going to use the information, we're going to use the formula and the factors of 50 in a table. So that was our problem solving strategy. We're going to be using a table today that show all of the possible combinations of dimensions with the volume of 50 cubic inches without repeating the dimensions of the bases. Okay, so it's important that all of the bases stay the same, okay, and we do not repeat any of those dimensions. Okay, and using this information will help us unlock that problem. So let's take a look at the next step here. So what we have is we have our table. So in order to start working through this table, we talked about all the different factors of 50. Okay, so the base cannot repeat itself at all. So what we know the volume is base area times the height, or length times width times height. So we think about all of these problems need to equal 50. Okay, all these multiplication scenarios need to equal 50. So we have 1 times 1, okay, for the base area, and then times 50 would give us 50. Okay, you can see, and you can even think about how we find the factors of a number. Okay, 1 times 50, we have 2 times 25, and 5 times 10. So 1, 2, 5, 10, 25, and 50, those are all factors of 50. Okay, so, and we multiplied 1 by all of these. Okay, and then we can see the height. We go from 50 to 25 to 10 to 5 to 2 and to 1 for the height. Okay, so we just do different scenarios here. Making a table helps us stay nice and organized, okay, for finding the volume of 50 cubic inches. Okay, let's take a look at if we start adding 2 to this table. Okay, so we can have the base area of 2 by 5. However, the height needs to be a little bit smaller, so 2 times 5 times 5 will also give us 50. You can fill this in as I'm going through these. Now we have 2 times 25 times 1 will give us 50. And these can be pretty much in any order. Okay, if you skip one or get messed up on one, or kind of go ahead, as long as you have all of these in here. 5 times 2 will equal 50. And then 5 times 10 times 1 will also equal 50. Okay, so completing this table makes it a lot more organized for us, and there would really be no way we could do this in our head, or maybe even trying to list them all as we think through them. Okay, so we can see right here our question: how many rectangular prisms with different bases can Adam make using 51-inch cubes? Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and finally 10. Okay, so how many rectangular prisms? We have 10 rectangular prisms. And I'll just write it right underneath here. Okay, let's take a look at the problem on page 448 in your math book. Okay, and it reads, Mrs. Wilton is planning a rectangular flower box for her front window. She wants the flower box to hold exactly 16 cubic feet of soil. How many different flower boxes, all with whole number dimensions and different size base, will hold exactly 16 cubic feet of soil? So the first thing we need to do is figure out, what do I need to find, what information do I need to use, and how will I use the information? So first of all, what do we need to find? In other words, we're going to focus in on that question that they're asking us. We need to find, and I want you to write this down in your book, the number of different rectangular flower boxes, each with a different size base, that can hold exactly 16 cubic feet of soil. So that's what we need to find. We're going to zero in on that question, focus in on that. Now, what information do I need to use? The information that we're going to use and that we need to understand that's going to help us solve the problem, some things that we need to know. The flower box is a rectangular prism. The formula for volume is volume equals length times width times height, or volume equals base area, which is the length times the width times the height. And also the exact volume of the rectangular prism must equal 16 cubic feet. Now, how will I use the information? We will use the formula and factors of 16 in a table that shows all the possible combinations of dimensions with a volume of 16 cubic feet. So those are the steps that we are going to be thinking through as we solve this problem. Okay, now I have my table set up to solve this problem. Okay, so the first thing we're going to think about is the base area. Okay, and some things we need to think about is our volume will always need to equal 16 cubic feet. Okay, so we could have the base area. We think about all the factors of 16. So we can start with 1 times 1. I know that's going to give me 1 times 1, and then the height can be 16. Okay, pretty simple there. So the volume, we have 1 times 1 times 16. Okay, that will give us 16. Okay, it's going to equal 16 here. Okay, now if we go to the next one, we have a length times 1 and a width times 2. Okay, of 2. Then the height could be 8. So 1 times 2 times 8 can also give us 16 as well. Okay, now we think through another factor of 16. Alright, we have 1 here still. 1 times 4. A length times 4. A length of 1, a width of 4. That means the height would have to be 4. So we have 1 times 4, and then times 4 as well. Now remember, whenever there's a number next to a parentheses, it always represents multiplication, so just another way to look at it will give us 16. So we have 1 times 16, 2 times 8, okay, 4 times 4 there. Now we can take a look at 1 times 1 by 8. Okay, 1 times 8, and then a height of 2. 1 times 8 times 2 will equal 16. Okay, now we can also 1 times 16, length of 1, width of 16, and then the height would have to be 1. So we have 1 times 16 times 1 will also give us 16. Okay, so you can even see how we're finding our factors. We have 1 times 16, 2 times 8, and then we have 4 times 4. We just have 4 listed one time. So just like you find the factors of 16, you'll list them just the same way. Okay. Next one, we can go down to 2. A length of 2, a width of 2, and then that means our height would need to be 4. So we have 2 times 2 times 4 will give us 16. We could have a width of 2 and a height of 4. I'm sorry, a length of 2 and a width of 4, and then a height of 2. Now for the sake of time and the length of this video, I filled in the rest of these. Now it's easy to see, we're multiplying by 1, we just list the factors of 16. And then what we do, we think about, then we go to the next factor. So we listed 1, multiplying everything by 1, then we can multiply everything by 2. Okay, so 2 times 2, 2 times 4, 2 times 8, okay, within the base area. Then we went to the next factor, which would be 4. Okay, 4 times 4. And then multiplying this by 1. Okay, so we can take all of this. Okay, we see 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to answer our question. Okay, which is how many flower boxes with different sized bases will hold exactly 16 cubic feet of soil using whole number dimensions. Okay, and we can see easily there 9 flower boxes. And making that table is really the only way that you can figure out all those different ways in order to get 16 cubic feet. Okay, I want you to complete this problem by yourself, and I apologize for the screen going back and forth. And when you press play, I'll have the answer for you. So pause the video now. Okay, so you can see that there are 6 different cakes. The key thing that we need to remember that the cakes are 4 inches thick, okay, and any whole number length and width are possible. Okay, so we needed to keep that in mind. So we need to think about what times 4 would equal 36. So we know that 90 times 4, equals 336. Okay, so we had to think of all the factors of 90, and that gave us the answer to our problem. So this does conclude the video about comparing volumes. Now our essential question was, how can you use the strategy make a table to compare different rectangular prisms? I can make a table to find all the combinations of 3 factors whose product equals a given volume and have different sized bases. If you have any questions about this concept, please come and see me.